friends, I am Dr. Bharat Modi from Wellcare Hospital, Vadodara. I have spent what I would think is almost an entire lifetime working in the area of total knee arthroplasty and arthroplasty at large, but certainly much more focused on the total knee arthroplasty. And on request of my fellows and students, I have decided to come up with a series of lectures which will take you through what I would consider as a primer and as an overview of understanding the science and art of arthroplasty. Friends, if you have any inclination to go into further personalized discussions on this matter, you are most welcome to approach us at Wellcare Hospital. We will be exhibiting the contact information for that. And for any questions that you might have, it will be my pleasure to help you understand and navigate your pathway in this area of work.
So these are topics which you might never focus your ideas on or mind on unless something like this happens in front of you. You know, even amongst your colleagues, at the most you will end up discussing मैंने ये कर दिया वो rod डाला कि नहीं कैसे incision लिया था. Those sort of aspects of surgical action you will discuss. But I would suggest that to be a comprehensive scientist level surgeon, not a technical level surgeon, you don't need to know all this if you just want to do a competent surgical exercise and be a good counselor and therefore get good business and get on with life, buy a Mercedes or whatever. For that you don't need this subject inputs. But if you want to be a genuine authority in the area of your work, then yes, this would be a useful thing to have. Next please. Next. So polyethylene. If you have one thing that is perishable in the area of joint replacement, it is this, polyethylene. The remaining parts are metals. Metals, unless they are subjected to an inordinate amount of stress, they are not going to perish. I'm not referring to infection. Infection is not a deficiency of the metal itself. Infection is something very different. Metal just happens to become an impediment if infection occurs. The real inherent weakness of a material is what I'm referring to here. So in that sense, metal is not something that will perish that easily, but the one thing that will perish is polyethylene. So it's important to understand. And why is it important to understand? Remember those selection of implants, the design of implants, all this has been influenced by the science of polyethylene. How polyethylene was understood by the industry first and then by the surgeons who interacted with the bioengineers, and how in that combination of thoughts and understanding of the biomaterial science combined with biological science, we have what we have today, and how it has improved the scenario for patients as well as for surgeons. Next please. So to be honest, whilst we keep on fiddling with things such as robotics, etc., which at the end of the day, they add value, if at all they add value. In fact, they don't add any real lasting value. But if at all they add value, they are still additions to the way in which we will do your surgical action. But the true frontier that is still open to arthroplasty arena, or people who are working in the frontiers of arthroplasty, the true area is the component material. In other words, the biomaterials of the implants that you put in is where the real true frontier is, where you can actually, if someone comes up with a new discovery or a new idea, that is where a multiplier effect can be generated of an immensely beneficial nature in appreciable clinical terms. When I commented on that robot thing, it was about it not showing what is known these days in technical jargon as MCID, minimal clinically important difference. This is a technical acronym, and in scientific papers, you have terms such as PROMs, patient reported outcome measures. I'll quickly just educate you on this. So in the early days, when I was a a youngster of your age, there was nothing called proms as a part of routine jargon when you read scientific literature. It was all about improvement in KSS, WOMAC, WOMAC being a Western Ontario scale, knee society scale, these sort of things. What were these? These were measurements that had been developed by surgeons, asking patient bend your knee, so the patient bent their knee, straighten your knee, straighten, and if the surgical fraternity decided that 0 to 130 was an excellent result, that was given the grade of excellent score. Never did it come to the aspect where you ask the patient to say that from 0 to 130, but are you happy with that moment? If the patient said no, I was expecting 150. Now that's a patient reported outcome measure, and that was a surgeon reported outcome measure. So later on, the entire understanding of this came along, that perhaps more important or equally important is to have PROM as part of your assessment of a clinical result, And then now this MCID is also a very useful thing, because you will come across hundreds of papers, especially in the modern day scenario where paper publishing has become a mass production thing, and statistics have become an incredibly effective tool of sort of confusing the casual reader. Because even at my stage, where I have been a reviewer of the Bone and Joint Journal, when they send me some of these papers, I feel completely incompetent because of the sheer complexity of the statistical aspect of that paper which they put forth. So this term MCID, minimally clinical important differences, is where you distinguish that 1 degree extra flexion moment given by a robotic methodology, RATCA, is of no real clinical importance, 1 degree, But if you don't mention that, and if you just take that 1 degree and then say there was a statistically improved clinical result without mentioning that it was 1 degree flexion, then you will convey a very different sense of what the message is coming out of that study. Whereas if you say that there was no MCID, although there was 1 degree, and then the reader understands that, oh, okay, it's only 1 degree, it is not clinically important, that difference, and so do I need to spend $1 million for a robot? So that's a very important aspect, MCID. I don't know how I came there, but this is how I came to this topic, that if I have to make a wager, a bet, that what is it that can give multiplier, not minimal, it will give maximum clinically important difference results, it will be improvements in the area of biomaterial in the years to come. Okay, next please. So from now on, more than geometry, it is the material of the components which will decide long-term results in arthroplasty, because we have already reached a peak, more or less, as far as geometry is concerned. There's not much else that you can come up with in terms of geometry. Next please. Hence, it is important that arthroplasty surgeons have a basic understanding of biomaterials forming joint components. Next please. The major long-term failure mode in total knee arthroplasty is polyethylene wear and its sequelae. You have debris, which is understandable as part of the friction. The debris causes osteolysis, and the osteolysis causes implant loosening. This is the sequence, whether in the hip or the knee. But here we are sticking to the knee, because there is a small difference between hip and knee failure mechanism. So that's why I want to clarify that we are sticking to the knee here. Next please. Why is wear important? Because it is over the decades of arthroplasty, younger patients started coming with the demand of getting their knees replaced, and even the older spectrum lived longer and remained active longer, and aspirationally became more demanding, that I want to still ski or go for mountain hikes and things like that. So that is why wear has become an important topic. Higher revision rates in younger TKR patients, as you can see, that overall reasons for revision surgery, polyethylene wear and loosening have the highest, 25% of the revisions that happen in knee replacement surgery is for reasons of poly wear and loosening, and then you have instability and infection.
So when they say they need a revision surgery because of polyethylene wear, I thought they will need revision surgery only when the process goes on to loosening and polyethylene wear.
So it's definitely, you are very good. I'm happy you picked it up as a separate issue or a subtle difference between the two. No, poly wear in itself, even if your implant has not loosened up, and you'll come across this quite frequently, especially in aseptic failures in the hips, even in the knee, but more so in the hips, where the debris generated has caused so much of osteolysis that if at all a patient has been in regular touch with a doctor or a surgeon who has done it, and they would pick up on the x-ray, oh wow, this is now, for example, if that patient actually turns up, then on 25th of this month, I am revising the hip of a man whom I implanted 25 years back and whom I casually picked up. He came to book the knee replacement dates for his cousin sister and just casually just showed me, sir, look at my x-ray, I did it last week. And then I picked up that, oh my God, this poly has already worn through, it's a Duralock cup. And at present, he just requires the change of a liner. But once the implants, the metallic part of the construct loosens up, he will require a massive revision. So I hope he has understood this matter. Incidentally, in fact, remind me after this lecture is over to reach out to him and confirm this. So poly wear and loosening. These are the important things. Next, please. Polyethylene, abbreviated PE, is the most common plastic with around 80 million tons being produced annually. So PE is not something that you use for only for your implants. Actually, that is the electron microscopic usage in terms of its volume of PE that might have been used in medical implications is probably an electron microscopic dot compared to its use in all other products that human population is using these days. Many kinds of polyethylene are known. Next. So low density. For your purpose, what you should remember is, forget the linear low density. Low density, high density and ultra high molecular weight polyethylene. So again, this is a bit technical, you don't need to remember this, but at least you should be aware that there are many types of polyethylenes: low density, linear low density, high density, ultra high. The one that you are going to interact with in your career is this ultra high molecular weight. Next, please. Polyethylene was first synthesized by a German chemist who prepared it by accident in 1898. The first industrially practical polyethylene synthesis was discovered in 1933, again by accident, at the Imperial Chemical Industries in London, ICI. It's a very famous group even today. A pill box presented to a technician at ICIC in 1936 made from the first pound of polyethylene. This is a historical antique thing, that a pill box was made. And at the moment I don't remember the exact story, but when I was preparing this lecture, I had also visited the entire story of how that accidentally. It was something where I think the chemist was doing something and the next day he came and he saw this fluffy white thing. And whilst it was interesting material, he didn't find any useful thing for it. It was actually, so here it goes. It was many, many years later, you can see almost 35 years later, that someone realized that, bloody hell, this material can be used productively. And then he made the first of the industrially applicable product out of that polyethylene, 35 years after. And then history is in front of you, that today human society, the way it is organized, cannot live without polyethylene being part of it. All of these, they are all polyethylenes. Anything and everything you interact with will have some component of this. So next, please. Factors affecting performance of ultra high molecular weight arthroplastic components. So now we are coning down on the ultra high molecular weight polyethylene, which is the only form of polyethylene that is used in our area of work. In that, what are the factors which actually affect? Say, neither am I a biomaterial scientist, nor do I aim to make you biomaterial scientists. We need to know just about so much of this understanding of this biomaterial that it becomes a useful thing to have and you become more informed surgeons. So it is the grade of resin, and I'll make you understand what it means, that grade of resin in the next few slides. It's also the manufacturing process of the base material and then the manufacturing process of the implant. The material, what is the base material and how is it different from the implant? The implant is this actual shape of this insert, this, but this is made out of some base material, so they come in the form of either rods, like a tree trunk. For example, this furniture, the journey of this sofa's present shape started with a tree trunk. So the tree trunk is the base material, whereas this shape that you see is the final. Similarly, this is the final implant material. And so how this is manufactured is also an important aspect of the performance of polyethylene in the body once it is implanted. But how the base material is produced is also an important part of how it affects the performance, clinically speaking. Next please. So various grades of ultra high molecular weight polyethylene resins have been available for orthopedic implant application, and primarily from this one company. So it's interesting, whilst you might find that you have, let's say, 100 device manufacturing companies offering you their product, but when you track the source of their polyethylene, it will boil down to at the most 2. This is again, these are early names. I think today DuPont, division of DuPont is there, and one is a standalone company, and I think Zimmer sources it from that other standalone company. So they are the world's only 2 suppliers of medical grade polyethylene. The last time that I visited this subject, I could stand corrected here. Primarily from Ruhr Chemie AG, which later changed its name to Hext. It's a Swiss company. Hext is a very famous company. I mean, every doctor should know this. It's one of the pharmaceutical giants in the world. It's a Swiss company. The Ruhr comes from the river Ruhr, which starts from the Alps, passes from the Swiss Alps, and then goes into Germany and then flows into the sea, which later changed its name to Hext and is currently called Ticona. But Hext is, of course, still there in the other parts of their business. It's some massive company. This is the only source material medical grade resin used by all implant manufacturers. So Gangotri ek ach hai. It's only later, the base material, and then later on the various device manufacturing companies, they modify the process by which they make this implant, and we'll see what those options are. Next please. Commonly used resins today in orthopedic implants are GUR 1050 and GUR 1020. The GUR stands for granular ultra high molecular weight Ruhr Chemie. So that acronym has stuck. Okay. The Ruhr Chemie manufactured granular ultra high molecular weight. It comes in the form of granules, the first production. They are all petrochemical products. So oil, as it is dug from the ground, that is fractionated. It's called fractional distillation, and various fractional distillation streams that are generated of the products which come out of that black material called oil. Of that one particular stream, again, as it keeps on getting broken down into components, and then one of those streams will lead to plastic at large, and from within that area, ultra high molecular weight polyethylene, which is a plastic, comes, and they are all formed in the form of granules when they are actually made, and then those granules are processed in different ways, and we'll see what it means. So the grade we are talking about are 1050 and 1020. So if at all you want to be very intelligent, or if not intelligent, but informed surgeons in discussions with some rare peer who is also that educated in these areas of work, then he will understand how deeply your knowledge is. 1020 ke 1050. Next. So the numbers following GUR refer to the following. The first digit refers to loose density. The second digit refers to the presence or absence of calcium stearate. This was a very important part of the evolution of implants in medical grade implants. The presence of calcium stearate. Calcium stearate is nothing but a powdery form. It was used as a lubricant, powdery lubricant. જેમ કેરમ ઉપર the carom board ઉપર જે I don't know whether carom board ઉપર calcium stearate, whether it is calcium stearate, but just like you use that to allow reduce friction. Similarly, calcium part of the manufacturing process, લખ્યું છે, which can be used as a lubricant to assist the processing of the material. It was only later on that it was found. It was standard practice to use calcium stearate in manufacturing processes related to ultra high molecular weight polyethylene, which initially started its journey as granules, as I said. Those granules would, for example, be sort of made into a block of material or a rod of that material. How that can be made, we'll talk in a moment. So I'm just educating you that how do these words 1050 and 1020 come along, So the first digit refers to loose density, the second digit refers to the presence or absence of calcium stearate. Next please. The third digit refers to the molecular weight and the fourth digit refers to the resin grade. So overall, don't get too obsessive about this. It's not natural for most brains to become really interested in these dry figures. So I can already see eyes glazing over and buccal muscles taking over of a yawn. So, so don't get too obsessed with it. All you need to know is that there are different grades of resin, and these resins are important in understanding the quality of the implant or the nature of the implant you are using. And calcium stearate, which you will see later, it is now no more part of the manufacturing process. Next please. So manufacturing process of the base material. Now we are discussing just to remind you, we had three things: grade of resin, manufacturing process of the base material, and manufacturing process of the implant itself. The grade I have just told you, primed you that there are these two grades that are relevant to our area of medical work, 1020 and 1050, and GUR 1020, GUR 1050. So what does it mean? You don't need to remember exactly granular, ultra high molecular weight, rural chemi. ये कोई याद रखने की ज़रूरत नहीं है. As long as you remember that there are these two grades, that itself is good enough. And then those figures have some relevance. They convey something. But more importantly, the calcium stearate part, which you will hear in a few minutes. So ultra high molecular weight is produced as powder and must be consolidated under elevated temperatures and pressures. Powder means the powder is made up of fine granules, It is produced, this is what I mean, it is produced either by compression molding or ram extrusion. Next please. The process of consolidation requires a proper combination of temperature, pressure and time. Temperature, pressure and time. At what temperature, at how much pressure, and how long is the pressure sustained, makes the same powder, which is now looking like a solid block of material, but it will have different types of characteristics, even with minor changes in these parameters. Minor changes. Because you might ask, why only one company in the world, only one company in this entire world makes, at end of the day, what is it? It's the polyethylene is produced in millions of tons by Reliance and by so many others. But why is it that medical grade polyethylene is manufactured only by one company? Because the sensitivity of its manufacturing process, and therefore the behavior of that material later, is so much dependent upon that precision that the hassle and eventually the volume is not worth the while of the large manufacturing people, So the precise combination of these variables, which are proprietary secrets, first of all, have a significant effect on the final performance of the product, जो अभी मैं बोल रहा था वो, और ये secret है. So that is the real key to that रूर केमी का अभी जो भी टिकोना जो नाम है वो, कि वो सारा किसी को मालूम नहीं है कि ये कैसे करता है. That is why this works so well. Next please. And now that calcium stearate comes, so fusion defects. it was only later on that it was realized. Now at present it is 1020 and 1050, but in the early days they were using GUR 4150 1120 type. अरे શું થયું देखना हाँ. So the calcium stearate which was being used as a lubricant, it's a powdery thing, which was being used as a lubricant in the overall process, those particles were getting incorporated within the polyethylene itself, and those fusion defects were leading to completely different behavioral things, behavioral aspect, physical properties of this material. And it was realized that if you take them out of this process and don't allow calcium stearate to be incorporated, then you will get a calcium stearate free material like this, and that the performance as required for medical use jumped dramatically. So today you have only calcium stearate free polyethylene available across the world. Next please. So calcium stearate is no longer added to orthopedic grade polyethylene since reports showed increased levels of oxidation and fusion defects associated with its use. However, some controversy exists. Oh, okay, that this is going into very much detail about the industrial discussions. Next, please. Now we are coming to the manufacturing process of the implant, and this is very important. बेस मटेरियल में आपने देख लिया रैम एक्सट्रूजन एंड कंप्रेशन मोल्डिंग, उसका मैं डिटेल में नहीं जा रहा हूँ, बट इनफैक्ट आई थिंक इन सम एक्सपांडेड फॉर्म ऑफ दिस लेक्चर आई हैव टाइनी वीडियो क्लिप्स एक्सेट्रा अबाउट व्हाट इट मीन्स रैम एज द वर्ड सेज, यू रैम इट, सो उसमें क्या करते हैं कि जस्ट क्विकली आई टेल यू, अ लॉट ऑफ दिस मटेरियल इज केप्ट एंड देन इट इज अंडर प्रेशर and a piston comes and rams it through a cylinder, so the entire thing comes out in the form of a round log, and compression molded ma it is not rammed through, it is pressurized into a block, so there are two different ways to turn that powder, granular powder, into solid blocks, and these two different mechanisms have slightly different slightly or significant difference in the material characteristics, physical characteristics of that final product. But now we are coming to and this is important. This I think you should, I would hope that you guys who have had the opportunity to interact with me should be a bit more educated on this thing, So first of all, across the world now the resin is either this or this, 1020 or 1050. Nobody uses that calcium stearate now. First and foremost, what happens is this resin, so it is polyethylene. Remember, polyethylene. So it starts as a monomer, but they get linked to each other, and that's how polymerization takes place. Your acrylic cement is also the same thing. That liquid and the powder, the liquid is called a catalyst. वो जब अंदर डालते होता है, that powder starts polymerization. And it's an exothermic reaction, that's why that rise in the temperature. Similarly here also it's a polymerization sort of response that happens. Irradiate to cross-link, which releases free radicals. It's important why I'm writing this. Again, this came as a later understanding. The release of free radicals. What are free radicals? Free radicals are highly active electron based particles, entities, one electron deficient molecules. So they are all the time looking to combine with something, and when they do so they cause oxidation. Your rusting जो होता है, that rust, which is a corrosive and destructive process, it is that oxidative process. So these free radicals which are released as part of the irradiation to cross-link the polymer, मोनोमर को पॉलीमर में बदलना है तो वो क्रॉसलिंक करना है, वो जो क्रॉसलिंक करना है उसके लिए आप इरेडिएशन करते हो, लेकिन जब वो क्रॉसलिंक करता है तो दैट प्रोसेस रिलीजेस सम एक्स्ट्रा इलेक्ट्रॉन्स विच आर known as free radicals, So you have to remove the free radicals, because unless you remove them, free radicals are corrosive in nature. They are very active form. you know. And then you are that rod here, they are showing it diagrammatically, they are showing it that rod form, you know, gram extruded, I guess, you know. So that free radicals, then you remove, there are processes to absorb these radicals out of that product up to a point. I don't think it can be zero, but it can be. And you will understand this later. आजकल आप लोग ने सुना होगा विटामिन डी एडेड पॉलीथिलीन, विटामिन sorry, D नहीं, E, vitamin E, and then the DPU has got in their attuned range called AOX. That AOX stands for antioxidant, you know. So वहाँ पर कुछ अलग सा उन लोग ने डाले हैं. These are materials which react with the free radicals and capture them, so that they don't end up continuing damage to the plastic at large. So this is what is known as doping of the plastics. ये आपको समझ में होना चाहिए, बिकॉज सो मेनी टाइम्स द कंपनी रैप विल से सर हमारा तो AOX है, बट ना तो पढ़ाने वाले को मालूम है व्हाट इज AOX, ना तो पढ़ने वाले को मालूम है व्हाट इज, खाली बस शब्द AOX है, सब 5000 ज़्यादा होगा, ये तो लेटेस्ट है बस ऐसा, यू नो. So stabilize and remove free radicals, and then you machine it into shape. And there are some companies, I think Zimmer is actually the only company, who mold it into shape, heat molding. Most of the time ये जो PFC सिग्मा है ना, वो मशीनिंग वाला है, यानी उसमें वो 3D कैड कैम मशीन से अंदर वो होता है, तो अ ब्लॉक ऑफ दैट रॉड में से करी नाखू मशीनिंग है. सो जेंटलमैन, आई हैव बीन सो लकी, आई टेल यू, आई डोंट नो, इट्स अ कॉम्बिनेशन ऑफ लक एंड एंथुजियाज्म, आई थिंक दैट ओवर माई करियर, यानी मैंने ये सब फैक्ट्रीज, द मल्टीनेशनल की फैक्ट्रीज के फ्लोर पे जाके आई हैव सीन दिस products being manufactured in their line, you know, कहाँ ना कहाँ. So over the years, when I reflect back upon my career, I've been extremely lucky. हूँ जारे इंग्लैंड, when I was doing my fellowship in Boston, तो बॉस्टन के पास में ही बाहर में, the name might be wrong in my mind, जैसा there's a small town called Amherst, I think. वहाँ पर ये अभी आप जो देख रहे हो ना शेवर्स, और स्मिथ एंड नेव्यू, और स्मिथ एंड नेव्यू took over that company called Dionix. डायोनिक्स की फैक्ट्री वॉज जस्ट आउटसाइड बॉस्टन, थोड़े दूर एक गांव था या गांव ही था वहाँ पर. तो मैं तो गया था मेरी फेलोशिप करने के लिए, बट वो रैप आया इन दैट लार्ज इंस्टीट्यूशन कॉल्ड मैसाचुसेट्स जनरल हॉस्पिटल, MGH में. तो मैं बातू नहीं हूँ, तो उसके साथ बैठ गया कि ये कैसे, ये कैसे होता है ये वो. तो बोलता है कि भाई माई फैक्ट्री इज जस्ट हियर. आई सेड कैन यू टेक मी टू योर फैक्ट्री टू सी. He got surprised because no resident asks like that. तो लेकिन जो भी है उसको भी ऐसा उत्साह लगा कि well okay, I'll arrange a trip, you know, I'll come with you. Normally they will not allow you to get in. So I went with him and it was such a fascinating, मैंने अजीब ही याद है, because I was always fascinated कि this tube, your arthroscopic shaver, see, India, China, these guys have copied the machine itself. You get your Indian shaver control units, even your hand units, but the shaver tips are still coming from the original manufacturer, which is either Smith & Nephew or Stryker, which means Dionix, and originally the form is that. Because, and I'm sure it's not impossible for China or some entity in India to do that here, but maybe that large entity has no interest in that a specialized thing, you know. So I saw in that how they do what is known as wire cutting at Indani tube ma, and then polishing the edge, and constantly water flowing over it to prevent the heat. It is still that assembly line is here in my brain, you know, into how they do it. So over the years I've had that opportunity to see all this on the floor as well, you know. And then lastly, sterilization, which is also an important thing. Next please. Most frequently done by gamma irradiation or electron beams. It induces cross-linking, but it also causes generation of free radicals, what we just now said. Next, after free radicals are formed, one of the three things can occur. It can rebind to hydrogen without change in the structure of the molecule, which means molecule means the polyethylene. This is neutral impact. Because free radicals are highly reactive, they cannot stand alone. वो किसी न किसी को पकड़ लेंगे, तो मैनी टाइम्स वो पकड़ लेते हैं और अपने आप को स्टेबिलाइज कर देते हैं. इट कैन बाइंड टू अनदर फ्री रेडिकल to form a cross-link with another polyethylene molecule, and this increases cross-linking, enhances wear resistance. This is a positive impact. So after the first generation of all polyethylenes are cross-linked by definition. All polyethylenes by definition are cross-linked. तभी तो polyethylene बनते हैं. But you will come across companies saying that, oh, this liner of the hip or this insert of the knee, sir, ours is a moderately cross-linked, ours is a highly cross-linked. So what is the meaning of that? What is the implication of moderately and highly cross-linked? वो भी समझोगे आप. इधर जो लिखा है ना पॉजिटिव इम्पैक्ट, क्यों? क्योंकि इट इंक्रीजेज व्हेन दिस पॉलीइथिलीन गेट्स मोर एंड मोर क्रॉस लिंकिंग, इट बिकम्स हार्डर. सो टू गिव यू एन एग्जांपल, दिस इटालियन मार्बल इज अ सॉफ्ट मटेरियल, but a granite is a hard material. So the same Italian marble in polyethylene terms, if more cross-linking occurs, it becomes a granite. But then what happens is that whilst it becomes more resistant to abrasive wear, it also becomes brittle. So it's a trade-off. Very high cross-linking and turning it into stone has the problem that the tiniest amount of flexural force generated on it will crack it and break it. So it has to be a sweet spot of increasing the cross-linking to a point where the abrasive resistance improves, but without reaching a point where the brittleness goes so much that a little bit of flexural tensile force will crack it and fracture it. So that's important. So what happens when you keep on increasing the duration of radiation and the dose of radiation? This radiation, that it starts off with cross-linking, but then it keeps on increasing. And so, for example, there are some, I think it is diffuse, and I think we'll have this slide. They are made moderately cross-linked at 5 megarad, and some other companies do it at 7.5 megarad dose, but nobody goes beyond 10, because then it becomes too much. It can, and the last thing, it can bind to an oxygen atom, cleave the molecular chain, oxidative degradation. This is a negative. मैं तो आपने कीधु ना कि free radicals are highly reactive. हाइड्रोजन से करके शांत बैठ जाते हैं. दूसरा ये करते हैं कि वो मटेरियल के साथ इंटरेक्ट करके वो क्रॉस लिंकिंग बढ़ाते हैं. और तीसरा, ऑक्सीजन अगर है, उसके सामने ऑक्सीजन है, तो ऑक्सीजन के साथ जब वो इंटरेक्ट करते हैं तो दे रिलीज, बाद में दे रिलीज what is known as oxidative, यानी oxidative process करते हैं. And this is very important. The simple thing, a very simple thing, that as soon as this was realized and they found कि यार हम लोग जब ये सब बना के ये फाइनल इंसर्ट को पैक करते हैं, स्टरिलाइज कर देते हैं, बट वी आर नॉट डूइंग इट अंडर वैक्यूम. So in that package of ours, there is a air present, and air has oxygen. So on the shelf, while the implants are sitting on the shelf, those free radicals within the plastic were interacting with that air surrounding in that package, and it was causing oxidative degradation, and therefore those plastics were failing earlier, and therefore those plastics were, even though the sterility date, remember, when you look on the box and it says okay till 2024 September, they are talking about the sterility date, not so much about the material reactions that occur. So from then on, all companies started doing their packing, sterilizing. कैसे sterilize करते हैं वो भी एक अलग बात है, but all of them started changing it into what is known as a vacuum sterilizing process. The बद्दी air काढ़ी नाखे, it would be a shrink wrapped. That's why when you open up your वो जो करते हैं, जब ऐसे कट करते हो चिपका हुआ होता है, वो पापड़ मिलते हैं आजकल फॉरेन ट्रिप में ले जाने के लिए, वैसे एकदम वैक्यूम पैक्ड ऐसे. सो द ऑक्सीडेटिव प्रोसेस, इट इज टू प्रिवेंट द ऑक्सीडेटिव प्रोसेस on your plastic inserts. Next. So wear versus gamma dose. So this is your wear rate, and this is your radiation dose, this axis. So what is it? What is it showing? Let's say if you had zero radiation, which means the polyethylene was minimally linked or cross-linked rather. Let's say zero radiation, minimal cross-linking, the wear rate was high. This is the wear rate. So this was high. But as you go further, when you start increasing the radiation dose, the gamma radiation dose, which means as you are increasing it, you are increasing the cross-linking. So from low cross-linking to moderate cross-linking to high, the wear rates drops from here till low, almost up to 0 तक आ जाता है, 0 तक. Now, important thing to see, that the beneficial effect of drop is best at around 10. उसके बाद प्लाटो हो जाता है. सो वेयर एब्रेशन रेजिस्टेंस प्लाटो हो जाता है, बट ब्रिटलनेस बढ़ती जाती है. दिस स्लाइड डज नॉट शो ब्रिटलनेस. दैट इज वाई most companies have, this is Lakshman Rekha 10. You will not find any company which offers its product at which has gone through a higher than 10 megarad. DPU has selected I think 5 at least for their PFC sigma range में जो होता है. AOX का मुझे नहीं मालूम है. और another company which I don't remember just now, they bring it at 7.5, but hardly anyone would ever cross 10 megarads, because then the brittleness becomes too much, and the wear resistance does not improve significantly after that, you know. So next please. So wear rate drops dramatically for radiation doses up to 10 megarads, जो भी मैं बोल रहा था. However, other physical properties are also affected, which means fracture toughness, yes, the others, the brittleness that I am talking just in, you know. So what next please? What they are trying to say is that there is a trade-off, the cross-linked stroke mechanical trade-off. मैंने जो अभी बोला वही, this is again repetition but in more precise chart terms, that the wear resistance up to a point, see once again here, the megarad, the gamma radiation dose, megarad जैसे जैसे increase होता है, green is the dose of the radiation, and as you can see mechanical properties वाला जो ये brownish orange bar जो हैं, mechanical properties here being resistance to fracture, you know. तो वो resistance कम हो रहा है, understand ना, this is resistance, this is inverse वो है. So the resistance is decreasing, in other words it is becoming more and more prone to brittle fracture. So जो अभी मैंने बोला वही है, but in a graphical form. Next please. The poly becomes harder, which means it is resistant to wear but also becomes brittle, so it is vulnerable to fracture. Next please. The other devil introduced by free radicals, वो जो मैंने बोला oxidation, which is a slow going process, and उसमें वो I just mentioned about the vacuum, वो same thing is being now shown. Next please. In vitro means outside, if packaging is done in air instead of vacuum, free radicals in the poly will react to the oxygen in the air within the packaging and will cause degradation over time before implantation. So this results in reduced shelf life. In vivo, oxygen in the body and fluid tissues will also, after implantation also the same thing can happen, but that you cannot actually prevent, by the way. बॉडी में तो जो ऑक्सीजन रहने वाला है, सो उसके लिए क्या होता है, this was solved by vacuum packaging. How can you solve this? Yes. So that is why the idea of then let us add something which will keep on capturing these free radicals within the substance of the polyethylene. Therefore, when you implant it, तो वो समय पे there are less free radicals around to sort of react with the oxygen in the body. Next, please. Therefore, for oxidative stability and production of poly properties, it is important to remove free radicals to the extent possible. Next, please. Oh my God. I'm thinking कि कितना हर एक लेक्चर में कितना होता है ये. This is the way in which how do you minimize free radicals. So there are two ways of annealing and melting. दिखाता हूँ. So remelting. So heat above melt point, a proven method, all free radicals recombine. So high oxidative stability, but does some additional loss of mechanical strength. So there are ways in which, again this is to do with the manufacturing process. We are going back to the manufacturing process here. Next please. And annealing. So what it means is, go back one slide. If you want to change the shape or make anything plastic, you heat it, not anything, but I mean you cannot, so you heat plastics basically. If you want to make it moldable, you melt it and pour it into a mold and that way it will take the shape of that mold once it starts getting back into the solid state. So the process of melting is common sense that we have learnt as children in the school. Is the process of annealing that you might not be very familiar with. So next please, annealing. You heat a substance just below its melting point. So it has become soft, but it has not melted yet. It is pliable but not liquid. So some free radicals combine but not all. In the process of complete melting, the advantage is that not all but maximum number of free radicals are taken up into, mean वो stabilize कर देते हैं उसको, हाइड्रोजन के साथ फिट कर देते हैं उसको, free radicals के रूप में they don't remain as free radicals within that thing. But what happens as a part of that melting option is that the physical characteristics of the material eventually change, which are not necessarily likable changes. In the process of annealing, which means you are making it liquidy but not liquid, taking the temperature just below the melting point, it is not oxidatively as stable as melting process, but there is less reduction of the mechanical strength of the thing. So like everything in life, there is always some loss and some gain aisa hai. And some companies stabilized on annealing as their methodology, and some companies went to melting as their, next. So recently, to try and overcome these annealing, melting, in the fight to take the free radicals out or at least stabilize them within the plastic, this idea came along, and that's the doping that we talked. Alternative, next, go back one please. Go back. So alternative to remelting or annealing, or as an additional step, you add this various materials or substances which are supposed to capture it. Next please. So the ideal poly is a trade-off. Standard polyethylene, you do some gamma ray radiation to increase the cross-linking. Depending upon how much you do, you can arbitrarily sort of use the word moderately cross-linked. Is a bit more, you can say highly cross-linked. Cross-linked poly, which is oxidatively unstable because this introduces those free radicals. But then to combat that, having created this poly, you again take it through a process of either remelt or annealing or adding of some dope. Samjhe? So understand, you have your standard polyethylene, which is a powdery form. You gamma radiate to create the polymerization thing. Now you have got a cross-linked poly, but which is oxidatively not as stable as you would want it to for this purpose, for the purpose of using it as medical grade poly. How do you then address it? By one of these three processes or a combination of at least two, this and that or this and that. And what is remelting? What is annealing? What is the difference between these two? Next please. And then lastly, you machine it into your desired shape. Now you've got your base material properly done, and now उसमें से जो भी बनाना है खिलौना वो बना सकते हो. Next please. And finally, you have done your machining and you come to the sterilization process. Here also there was originally it was the sterilization was done with gamma radiation because it was cheap, easy, until it was realized that your sterilization itself can also keep on increasing your cross-linking to begin with. So now it is done at low 2.5 megahertz, or it is done either with gas plasma or ethylene oxide. Next please. So key things to remember. Next, choose this resin GUR 1020 or 1050. Next please. Irradiate to so if you want to flaunt your recently acquired knowledge, next time you talk to your colleague or a industry rep, say na कि which GUR कौन सा GUR grade use कर रहे हो, and for a few minutes you will be able to preen your feathers. Irradiate to increase wear properties, which means cross-linking. Oxidatively unstable. This first step is oxidatively unstable. So next, to stabilize it, you will do either remelting, which is more effective in terms of taking out the free radicals, but then it reduces the mechanical strength. Or you can do annealing, which means raising the temperature just below the melting point it is less effective to take the free radicals out, but it is friendlier in terms of mechanical strength reduction. Next, please. And you can add antioxidant to look after the remaining or residual free radicals. Next, please. And machine to shape and sterilize. And lastly, next, sterilize का बात नहीं किया. So summary, what was yesterday? This was the Chandley historical, this grade, RCH 1000 HDPE, high density, not ultra high molecular weight polyethylene, high density polyethylene. Chandley started his journey with this. Next, please. Then came the various Ruhr Chemie developed, polyethylenes. Next, please. Then gamma sterilization was done in air with 2.5 to 4 megarad sterilization process. We are jumping straight to sterilization process. Okay, and now it is only done here and not in air but in vacuum. Next, please. Use of calcium stearate in the manufacturing process as a lubricant historically, which is once again now not being done. Next, please. And what is today? Next, please. We use only one of these two grades. Next. We have stopped using calcium stearate in the process. Next. Gamma electron beam radiation is done for cross-linking but in a very controlled manner, certainly not more than 10 megarads. Next, please. Thermal treatment, which I just said, remelting or annealing, which means after having done this gamma radiation, created your polyethylene mass, you once again treat it either by remelting or annealing to take away those free radicals, which this process would have inevitably caused to happen, no matter at what radiation. Even if it is at 5 megarad or 7.5 megarad, some amount to hona hi hai free radical generation, and that is what is being addressed in this next step. Next, please. And then finally sterilization with gas plasma, ETO, etc., and in vacuum basically. Next, please. And vacuum packaging. Yeah. So, and tomorrow, what can be possible? Additional products that you can find, whether vitamin E or kal ko kuch aur jadi butti mil gayi, Next, please. Improvement in material grades, manufacturing. Because there is enough scope here. Geometry, there is not much scope left for the human knee ki geometry. There is not much scope left about coming up with a new incision starting from the skull and doing, So all those areas are fully saturated. The only area which still has, in theory at least, umpteen number of options available to explore and therefore come up. For example, this is more about purely, let's say you get a polyethylene manufacturing process where you add antibiotic into it whilst not compromising on anything else, and that antibiotic keeps on leaching out, or a bug, if it sits on that poly, it will automatically get killed. The same applies to metal implantation of antibiotics. Fantastic. Not minimally important clinical difference, maximally demonstrated clinical difference. So the biomaterial, which I started my early slide in the first slide, that's the real true frontier. Next, please. Maybe just change the material. Why poly? Go to ceramic. And you have the first ceramic knee introduced in India recently. So go to ceramic. So I am saying biomaterial. Cost implications, some other, वो सब अलग बात है. But the opportunities are humongous, and there is no ring fencing of the knowledge here. Whereas there is ring fencing of the knowledge in terms of surgical technique and in terms of the implant geometry. Next, please. Summary, the ideal poly is a balance of wear resistance, oxidative stability and mechanical integrity. Mechanical is that toughness against fracture. Oxidative stability is something that does not keep on worsening as time passes by, and wear resistance is the real issue that all this discussion started with. Next, please. Yes, sir, this is just in case you will go back one. Stop it here. So these are just this is a useful slide just in case there are so many different brand names now with which these companies offer you products that at some point you need to be familiar with it. वो बोलेगा सर मैराथन लाइनर मैं देने वाला हूँ आपको, या एल्ट्रेक्स दे रहा हूँ, तो आपको मालूम होना चाहिए कि व्हाट इज एल्ट्रेक्स. फॉर एग्जांपल एल्ट्रेक्स इज देयर एडिशनली क्रॉस लिंक, सो वो 7.5 मेगारेड पे उन लोग ने क्रॉस लिंकिंग किया है उसमें. वेरेज जो सिग्मा क्रॉस लिंक और मैराथन, ये दो जो उनके थे, वो 5 मेगारेड पे है. And the process of stabilization, DPU has standardized it as at remelting for all their processes. They do only remelting, whereas Biomat, which is now part of the Zimmer group, वो mechanical annealing करके करते हैं, thermal annealing. So what I have taught you is a basic understanding. There is a humongous science, detailed science to all this. But ये जो स्ट्राइकर का क्रॉसफायर और X3 है, जिमर का longevity और ड्यूरासुल है, ये सब, these are brand names that in my days when I started this subject, etc., I used to, my focus and my understanding of each of these terms went up to this level, okay, I was familiar. Thank you. Okay. Okay, good.
Why is the first place we went for a polyethylene thing like that?
In the very first place, you mean? So the yatra started with something known as Teflon. Charnley ने चालू किया था ये सब. Teflon turned out to be extremely soft material. So वो फटाक से सब, it was a disaster. And from Teflon, Charnley then went on. He realized that maybe a better material would be poly. So see, so many of things that you see today, it is as much science as serendipity. Serendipity means ittafaq. The equivalent of that is ittafaq. So let's say if I have to start just now, if I give you an assignment, कि ओ भाई यहाँ पर एक मुझे किला बना के देना है. Now if you are on a beach, you will start with sand. But if you are in a village pond area में, you will start with clay. तो वो इत्तेफाक से अब आपने क्ले से चालू कर दिया, बिकॉज इट वॉज मोल्डेबल. जो किला बनाना था, कासल बनाना था, तो आपने चालू कर दिया, बिकॉज आपकी असाइनमेंट तो दे दी है कि आपको मुझे किला बना के देना है. आप पहाड़ के पत्थर वाले पहाड़ पर हो तो आप पत्थर में स्कल्पटिंग करके करना चालू करोगे. अब उसमें से अगर वॉट एवर यू चोज टर्न्ड आउट टू बी सक्सेसफुल एंड यू केप्ट ऑन डेवलपिंग इट, then वो आगे निकल गया. The same thing, he might have started on a beach with sand, but you started with stone on a mountain. So obviously that was more durable. So at some point your method became much more acceptable. फिर वो commercial हो गई. It got amplified. It was adopted by all and sundry. So there is a lot of and then what happens is, so it's a good question actually. So why polyethylene? Why not something else? Initially, that material could have been chosen purely by ittafaq, कि भाई it is moldable, something like that. Because even in early days, the hip का जो history of hip implants अगर मैं आपको बोलूँ, तो उसमें मक्की फरार और ऐसे थे कि जिसमें the cup was made of metal. It was metal ball against metal cup. But metal ball against metal cup, in those days the polishing etc. was not industrially so it failed. There was too much metal debris generation. Then metal on metal again revived after many decades, because the industrial manufacturing prowess became so much that they could come up with a bearing of metal on metal, but with so much fine polish and so much highly titrated tolerance levels that it did not create that thing. But it created, even then it created, that is why metal on metal is withdrawn. Because in the laboratory studies, it did not create a hassle because everything was hunky-dory, exactly at 45-degree inclination, exactly at this. In real life, a surgeon might put it a little bit like this, and the moment that inclination changed, there was more pressure on the edge, and that pressure started eating into, the metal started eating into each other, and that generated metal debris and led to all those tumors, etc. And therefore metal on metal was taken back. So a lot of to answer your question once again, or why poly, is to start with is serendipities. Charnley and the early surgeons found that to be a useful thing. And then once it becomes standardized and the compliance related issues gathered momentum in the world, which means if you have made one tiny mistake, then billions of dollars worth of litigation will come your way. It is a combination of science, of serendipity, and commercial and compliance related regulatory forces. All this put together brings to the final level of what you are doing. Okay, good. Let's start.